Naming acids and bases. So to start, I have several acid formulas and acid names. So when we look at acid formula, we see that all of them start with H. So the H isn't really going to be a good basis to give these guys a name. So instead, when we're naming acids, we look at the thing that isn't hydrogen. And based on what that anion is called, that's how we determine the acid name. So for example, here we have chloride, fluoride, and bromide. All of those end with IDE, and when you look at how they're named as hydroblankic acid. So hydrochloric, hydrofluoric, hydrobromic. Next, we have some acids that contain polyatomic ions. So here I have nitrate, carbonate, and sulfate. All of those end with ATE, and notice that they are all named as blankic acid. So nitric, carbonic, or sulfuric acid. The last group here, we still have polyatomic ions, but here I have chlorite, nitrite, and sulfite. So all of these end with ITE, and notice that they're named as blank us acid. So chlorous, nitrous, sulfurous. A good tip is that whenever it ends with ate, it's going to be one more oxygen than if it ends with ite. So for example, nitrate is NO3, nitrite is NO2. Sulfate is SO4, sulfite is one less oxygen, and it's SO3. So when we name an acid, we need to figure out what the thing that isn't hydrogen is called, and then we name it based on that. Now, we might have some polyatomic ions in our acids. So for example, phosphate, nitrate, these are all examples of polyatomic ions. There's many atoms, but it behaves as one ion. So for example, nitrate here has one nitrogen and 3 oxygens, but it behaves together as one single ion with a -1 charge. My monatomic ions are just one atom. So for example, chloride is a monatomic ion. There's only one atom, and it has an overall charge of -1. So how do you know you have an acid? The formula is going to start with hydrogen, or the name is going to end with the word acid. You want to make sure, just like whenever you name your ionic compounds, that your charges add up to 0. So your charge should overall be neutral on your acid here. So based on whatever the anion is called, whether it ends with ide, ite, or ate, that tells us how we're going to name the acid. So when it ends with ide, we're going to name it as hydroblankic acid. If it ends with ite, it's blank us acid. And if it ends with ate, it's going to be blankic acid. So let's take a look at question 1 here. We want to identify the anion ending, and the stem, the name that we're going to use for the acid. So my first anion is Cl-1. So whenever we have chlorine in a compound, it becomes chloride. So this ends with IDE. So we know this is going to be a hydroblankic acid. And this chlor here is going to go in the blank. So that gives us our hydrochloric acid. Let's take a look at our next anion. My next anion is ClO with a -1 charge. This is a polyatomic ion, and it's called hypochlorite. So because this ends with ITE, we're going to name this as a blank us acid. So hypochlor is going to go in the blank here. So go ahead and pause the video and take a couple of minutes to try the next 3, and then return here when you are ready to check your work. So my next anion is ClO2 with a -1 charge. This is called chlorite. Again, it ends with ITE, so we're going to name this as a blank us acid. And this chlor is going to go in the blank here. Next, I have ClO3. Notice that this is one more oxygen than chlorite, so this is going to be called chlorate. It ends with ATE, so I know this is going to be a blank ic acid, and chlor is what's going to go in my blank here. Then I have ClO4, and this is called perchlorate, one more oxygen than chlorate. So again, this ends with ATE, so I know it's going to be an ic acid, and we're going to put perchlor in the blank here. So hydrochloric, hypochlorous, chlorous, chloric, and perchloric are all very different acids. They have different chemical formulas here. So it's a bit like whenever you learn another language and you learn how to conjugate verbs. It's a little bit like that. So these guys have slightly different names, and they have completely different formulas. So for question 2 here, you've got some practice. So go ahead and pause the video and take a few minutes to practice question 2, and then return here when you are ready to check your work. So my first acid here is H2S. So S is sulfur, but in a compound it becomes sulfide. So we know it's going to be a hydroblankic acid. So this sulf is what's going to go in the blank here. Now sulfur acids are a little bit different in that we would probably call this hydrosulfuric acid, but if you had hydrosulfic acid, I wouldn't mark that as wrong on a test. It's just kind of an exception for these acids that have sulfur in them. Next, we have HCl. So Cl in a compound is called chloride. So once again, this is going to be a hydroblankic acid, and we're going to put chlor in the blank. Next, we have H2SO4. SO4 is called sulfate. So we're going to name this as a blankic acid. So this would be sulfic or sulfuric acid. ClO4 is perchlorate, so this is going to be an ic acid. It's going to be perchloric acid. SO3, one less oxygen than SO4, is sulfite, so this is going to be an us acid. So we would put sulfus, or you could put sulfurous acid. Both of those would be correct. Next we have ClO2, which is chlorite. So again, we have an us acid. This is going to be a chlorous acid. So take a minute to pause the video and practice with question 3 and return here when you are ready to check your work. So for my first acid, I have HNO3. This is nitrate. So this is going to be an ic acid. We would call this nitric acid. NO2 is called nitrite, so this would be nitrous acid. Br is bromide in a compound, so this would be hydrobromic acid. So now we want to go in the opposite direction. We have names and we want to figure out the formulas. So my first acid here is hydrofluoric acid. So this tells me that my anion originally ended with "ide." So this is going to be fluoride. So my acid formula is going to be HF. So H forms a +1 charge in compounds, and fluoride forms a -1 charge in compounds. So that formula is already neutral. Next, we have carbonic acid. This is an ic acid, which tells me that my anion originally ended with 8. So this was originally carbonate. Carbonate is CO3 with a -2 charge. Hydrogen has a +1 charge, so that's why we need 2 of them, so that my overall charge is neutral or 0. Lastly, we have nitrous acid. This tells me that my anion originally ended with "ite," so this was originally nitrite, which is NO2 with a -1 charge. Hydrogen has a +1 charge, so these charges balance out and add up to 0. So how do you determine the name and formula of a base? The good news is that you already know how to do this if you can name ionic compounds. So a base is generally an ionic compound that produces hydroxide when it's added to water. They are named in the same manner as other ionic compounds, except my anion here is always going to be hydroxide. So let's take a look at a couple of examples here. So in my first one here, I have Na. Na is sodium. And I don't need a Roman numeral for sodium because its charge is always +1. So this is just going to be called sodium hydroxide. My next one is potassium hydroxide. So potassium is K and hydroxide is OH. K has a +1 charge and hydroxide has a -1 charge. So these charges balance and add up to 0. So go ahead and pause the video and try C and D and then return here when you are ready to check your work. So my next base here, I have iron. Iron is a transition metal, which means I don't know what charge it forms. So I have to figure it out. Hydroxide is -1 and there's 2 of them. So my negative charge is -2. So my positive charge has to be +2. And there's only one iron, so that one iron must be +2. So we would call this iron 2 hydroxide. Next we have iron 3 hydroxide. So iron 3 is going to have a +3 charge, whereas hydroxide has a -1 charge. So whenever I have my formula here, I'm going to need 3 hydroxides for each iron.